Okay, this lesson is on dividing polynomials, which introduces a new rule for exponents. It's called the quotient rule. It says when you're dividing like bases, you subtract the exponents. Now, when we were multiplying like bases, we added the exponents. When we're dividing, we subtract the exponents. Okay, so here's why we do that. If I were to expand this out in the top, 7 to the 9th power means I got 9 sevens up top. And 7 to the 5th means I have 5 sevens in the bottom. Well, whoops. In order to simplify this, what we can do is we can cross out a 7 with a 7 on the bottom and do that until all the sevens in the bottom are gone. Now notice up top I've got sevens left over and I've got 7 to the 4th power. Well, instead of doing all this, writing it out and doing all that stuff, we're going to use the shortcut for subtracting the exponents. So we would still have a 7, leave the base alone. It'd be 9 minus 5, which is 7 to the 4th power. It's supposed to make life a lot easier using these exponent rules. That's always the top minus the bottom. Let's look at this one. It's negative 3, 4 is up top, minus 2 in the bottom, gives me negative 3 squared. If you can simplify, then you want to simplify. Negative 3 squared is positive 9. All right, let's look at this one. My base is 5. My top exponent is 10. My bottom is a 6. 10 minus 6 is 4, so it's 5 to the 4th power. So we're just straight up subtracting. Leave the base alone. You don't change the base. If I start with a 5, my answer ends with a 5. If I started with a negative 8, my answer will end with a negative 8. You have to keep the base. Let's look at this one. That should be x. Okay, so my base is x. Top exponent is 30. The bottom is 8. 30 minus 8 is 22. So that's my answer. Don't overcomplicate this. Now on the next one, you can see the bottom doesn't have an exponent. I mentioned this before, but if you have anything that doesn't have an exponent, it really has a 1. Stick the 1 there. So now what we have is my base is y, 10 minus 1, y to the 9th. Now this one's got 2 variables. An easy way to think of this is however many x's you have in the bottom, you're taking that many from how many you have in the top. So I've got x cubed up top, I got 1x in the bottom, I take 1 away from 3, and I'm left with x squared. I got 4y's up top, 2 in the bottom, I take 2y's away from the 4y's, and I'm left with y squared. Alright. When we subtract exponents, sometimes we will get a 0 as my exponent. Let me just show you over here. Suppose I had x to the 9th over x to the 9th. When I subtract the exponents, I get 9 minus 9, which is 0. Well, whoops, back up a little bit. We can't have, well, we can't leave a variable or anything with a 0 exponent. So, as a rule, if you have a 0 exponent, you replace that with a 1. It simply simplifies to a 1. There's no b left, there's no exponent left, there's no x left, there's no whatever. It's always just equal to 1. This rule can be a little bit tricky. Let's look at this. Now, the base is 3, the exponent is 0. The rule says whatever the base is, if my exponent is 0, it's automatically equal to 1. Look at this one. It's negative 6 to the 0. Now the negative 6 is in parentheses. This makes a big difference. Because the 0 is outside the parentheses, my answer becomes 1. The bottom one, this one, the negative 6 with the 0 is a little bit different. The 0 is only attached to the 6. This negative sign stays with whatever the answer is. Now 6 to the 0 is 1, and the negative comes down, so in this case it would be negative 1. Notice the difference between this one and up here. They both have negatives and 6s, but one of them has parentheses and the other one doesn't. So if you don't have a parentheses, your answer is going to stay negative. Now look at this one. Now this one has a negative 3 and an x squared in parentheses. Well, it doesn't matter what's in a set of parentheses. If the exponent is 0, automatically equal to 1. Now 13x to the 0 is similar to negative 6 to the 0. The x is the only thing that has the 0. So the 13 is still there. X to the 0 is 1, and 13 times 1 is 13. So where the 0 is makes a big difference, y'all. Look at this one. Now, there's a negative 6 and an x, but it's all in the parentheses. And on the outside is a 0, so that would just be a 1. Now let me just, if I had this, that's different than what I just had with the negative 6 in parentheses. This, just the x has the 0 exponent, so this would simplify negative 6 times positive 1, which is negative 6. Gotta be careful with these 0 exponents. This one, everything's in the parentheses, there's a 0 on the outside, it's automatically equal to 1. There's no x's, there's no y's, there's none of that stuff. It is what it is. Same thing down here. All of this is inside of parentheses with a 0 exponent. So regardless of what's in the parentheses, because that 0 is there, we just replace everything with a 1. 0 can be a little tricky. You gotta be careful. Alright, now with these fractions, there's that rule that said if you got exponents inside and outside the parentheses, you multiply the exponents. Same thing holds true if you've got fractions. We're still doing that special multiplication rule. So my answer is going to stay a fraction. We multiply the 3 by the 9. We get 27 on the x. We multiply the 3 by the 5. We'll get 15 on the y. This one. Now, remember I said if anything doesn't have an exponent, put a 1 there. I'm going to put a 1 attached to this 3 so I can use that exponent rule that says to multiply. So we're going to multiply 3 times 1. This gives me 3 to the 3rd power. 3 times 2 gives me x to the 6th power. 3 times 3 gives me y to the 9th power. simplify if you can. 3 cubed is 27. Got x to the 6th up top, y to the 9th in the bottom. So if there's no exponent, put a 1 there. I'm telling y'all that'll make it a lot easier. This one, let's do the rule for exponents. We multiply the 4 by the 7, we'll get 28. Still got a 2. Multiply the 4 by the 3, we'll get 12. So I have 12 to the 28th over, I have 2 to the 28th over 12, 2 to the 12th. Now, these have the same base, so we can use the rule for subtracting the exponents, and we'll get 2 to the 16th. So I was able to do 2 different things here. Multiply the exponents by 4, then subtract them because the bases were exactly the same. Same base. Whoops. All right, let me back up. Now look at the last one I have ready. None of those inside parentheses have an exponent, so I'm going to attach a 1 to each exponent. To each piece. Then we can use the multiplication rule for exponents. So we'll have 5 to the 2nd power, x to the 2nd power, y to the 2nd power. Simplify, and we'll get this. Now,